Hi everyone. RSES is a freely available software system toolset for analyzing tabular data sets utilizing various methods. So I'm here to discuss about the different data analysis methods in RSES. During the knowledge discovery process, first the data is loaded into the system and then pre-processing of the data is done. So once the data is loaded, it is very much important to pre-process the data to remove any discrepancies or any missing data. And then the interpretation or the evaluation of the discovered knowledge is being made. Missing value completion, discretization, linear combination are all the methods that come under the pre-processing of the data. Missing value completion. First, what is a missing value? It is just a data that is not either collected or that the attribute is not applicable in that specific case. For example, a child annual income. So RSES offers four different approaches to issue this missing value. Missing value could be represented as a missing or null or a question mark. So coming to the example of the missing value completion, we see that this example has four objects and there are five attributes: temperature, headache, cough, cataract, and disease. The first object, we see that all the data is available and there is no missing data. But when we come to the second object, we see that the headache value is missing. So the first approach of RSES says that we could just remove this complete object from evaluation, or the second approach says that we replace or complete the missing data with the main or the commonmost value. The third approach says that we could disregard this object during the reduct or the rule calculation. And the fourth approach says that we could treat this missing value as valid information, as we treat 7, 3, or 1. Cuts, discretization, and grouping. So we generate cuts and decompose the attributes, or we group the nominal attributes using two different methods, which is local discretization method or global discretization method. The main difference between the local discretization or the global discretization method is local is inclusive of the symbolic attributes. Whenever there's an attribute on which we want to cut, and that being of a type symbolic, we have to use a local method because global is not valid. Coming to the example, we see that temperature being an attribute of type numeric, and there is a one cut that is made and it divides it into two intervals, that is an interval which is less than 38.5 and the other interval which includes 38.5 or greater. In the second example, we see that cough being an attribute of type symbolic, this divides into two subsets. The first subset will have missing and no, and the other subset will have any other values that cough takes other than missing and no. And all these cuts are stored in the file extension .cut. The third method, linear combinations. Linear combinations makes it possible to add a new attribute to the decisions table. So this new attribute could be a derived attribute that is formulated from using the existing attributes. And all the linear combinations are stored in the file with an extension of .dir. In this example, we see that there are three linear combinations, that is three directions. Coming to the first row, it says that temperature into 0.707 plus headache to 0.707 would lead us to a new derived attribute. The fourth method, Redux and the decision rules. Redux are often the attributes that could be removed and still they conserve the same properties of the original data. This method is used by RSES to identify any discrepancies in the data. All the Redux are stored in the RSES file with an extension of .red. In this example, we see that there are 5 Redux and each description of each product is disclosed in between the flower braces and a number preceding it. The number represents the positive region. In this first row, we see that our product contains two attributes, temperature and headache. The value of the positive region being 1.0 means that the reduced table with the original decision attribute added is consistent and it has no discrepancies. Decision rules. These make it possible to classify the objects, that is, assign the value of the decision attribute. All the decision rules are stored in RCS file with an extension of .rul. In this example, there are 16 rules and 4 decision values. The decision values are angina, influenza, cold, and healthy. All these decision values are determined by the conditional probability of the rules, that is like very similar to if and then cases. So the first rule says that if there is a patient who is having a temperature of 38.7, that's a mild fever, and a headache of 7, it would determine that the sickness is identified as angina and that there is only one case that supports this rule. The support is usually determined in the square bracket. By support, we understand the projects in the training data that match the conditional part of the rule. In the last example, it says that whenever the category is no, the disease that is identified as angina, cold, or healthy, and the total support is determined as 3.